All right, Jessica, I see you are here already, and Haley is here also. So both of you are now in group 2. You're in group 2. So group 2 had 4 people before because somebody dropped out. So now both of you will make them 6.
Who are you adding, Professor?
That is for Jessica and Haley. Both of you are now in group 2, the pink group. Okay. Okay, so for recapitulating on the announcements again, I gotta say that so far you are doing good in handing in your work on time and including all the names on the list. So please continue with this plan. However, do not double submit. In other words, if you have submitted once, do not try to do it again, because once you submit it, it comes here. Even if you don't see it, I already received it. And most of the time when I print it, I'll tell you, I got it, thank you. Again, do not be late. And be sure to list the names of the members. And again, be sure to let me know whether you are in the afternoon section, which is 9078, or in the morning section, which is 9074. So you either indicate your section by that number, or you say it is afternoon section, or PM section, or 3 PM section. But so let me know where you belong. Okay, so with that, let's go to the lab.
Professor, did you say something about the pink group?
The pink
Yeah, what's
group,
Haley's last name?
That's Haley and Jessica are now added to the pink group, group 2.
What's Haley's last name?
Oh, Haley Herrera.
Okay, I'm gonna create a new group.
Okay.
On Canvas, I'm gonna create a new group.
Are they being added to the pink afternoon?
Yes, the pink afternoon, because they're in the afternoon enrollment.
Okay, cool.
So Jessica is Truong, T-R-U-O-N-G, and Haley is Herrera, H-E-R-R-E-R-A. Okay, so we're doing atomic emission spectra today, and it should have been loaded in my system. Okay, maybe it hasn't. Okay, I go to atomic theory, and I'll check the atomic emission spectra and it will load right there on the screen. And if I share the screen, you're gonna see it. And then you guys will be on the sides. Okay, just like the lab of yesterday, in this one, it has also questions 1 through 10. So like you did the other time, you will say, come on, get out. The first question is telling us to open this spectrophotometer. And then question number 2 is asking you, how many distinct lines do you see and what are their colors? Just like the same question is asked us yesterday. And so you're looking at this black section, and you can see that there are 1 and a faint one there, and a distinct green here, and a distinct red. So you've seen 4 lines, and identifying from left to right, you have a faint blue, you have a purple, you have a green, and a red. All right, so now the next thing, just like yesterday, next thing it wants us to do is to expand this scale by clicking visible full. Okay, so now we can still see the faint lines over here and very distinct line here and there. So to identify the wavelength, if we place the cursor on this teeny-weeny peak, it will read 410.8 something, and we abbreviate it, round it out to whole number. Place the cursor on the next line that corresponds to the purple, and it, and it should say 434.3575. So you again round it off to 3 significant figures, or round it off to whole numbers. And you go to the next line, you put your cursor there, and it should say 487.15 something. So you round it up to the nearest whole number, and it should be 487. And the final line, the one to the extreme right, again, you place the cursor there, and when it is directly on the cursor, you should say that it is 657. And so you write 657. Of course, if your finger moved, it could read 656. Now, then we go to the next instruction. Yesterday, we calculated frequency, no, not frequency, the wavelength and the, let's see, I'll bring my board over here. Can you see the whiteboard?
No, we can't. No.
Okay, I'm going to get out of sharing. Can you see it now?
Yeah.
All right. Is it readable? Can you read? Can you read this? The writing on the board?
Not
There.
that much.
Yeah.
No,
Is it making sense, or is it gone away? It's still there.
It's just a little bit blurry.
All right. So then, what I'm going to do is to wipe all this, and then we write it. We write it as we talk.
Okay.
I thought it was going to be easier, or well, not easier. Just let me do it without having to write it again. So we have the question or the instruction tells us that we have, from what we got from number 2, we have 4 different lines. And again, following from number 3, we identify the values as 410, 434, 487, and 657. The unit is nanometers. So we're going to write that here. From left to right, we have 410 nanometer and 434 nanometer and 487 nanometers. And then we have 657 nanometers. It might not be big enough, but if you see me writing it, you can understand what I'm writing. Okay, so then for each of them, it wants us to calculate the frequency. And perhaps from your lecture, we have this information that when a wave of light is emitting, it goes in sinusoidal wave. And that thing we call the wavelength is the distance between the peak and another peak. So this is the wavelength.
Professor, is the first number on the line, is it 410?
Yeah.
Okay, thank you.
Okay. So that is the wavelength, which means how long the wave is. Then in this particular lab, we are introducing a new term, which is the frequency. And that means how often do you see that particular wave complete a cycle in 1 second? So how often does a whole wavelength repeat in a cycle? So when you see this type of thing, if it is if the wavelength is long, then it will be a sluggish wave. But if it is short, then it means it will complete a cycle faster here than that. So while this first one will be sluggish, this lower one will be a whole lot faster. So what we are calculating now is the frequency, which means how often that wave should complete a cycle in a second. And in number 4 of the instructions, it tells us that we should use the wavelength of each line to calculate the frequency, given that frequency is frequency nu is equal to the speed of light divided by the wavelength. And again, we said we can calculate the energy of each of those waves with the equation energy is equal to Planck's constant times the frequency. Yesterday we talked about this and we didn't talk about frequency. So now it wants us to use this information to calculate the frequency of that wave and the energy of the wave. Okay, so I'm going to check this off because it will cost it. So now the first thing it wants us to calculate is the frequency, and we're going to put it in this first column. So frequency is equal to speed of light divided by the wavelength. And this time we know that the speed of light is equal to is given to us 2.998 times 10 to the 17 nanometers, okay, per second.
Professor, I can't see that.
Is it far away?
Yeah.
If I move it, can you see it now?
No.
There's a glare on it.
Yeah.
You can't see that? Is it because it's too small or is it because it's not on in the camera?
It's a glare. Like
It
from the window, your window's.
The window is, so that is why I want it this way, because the window is trying to. Does that improve it? Nah.
Yeah, that's better.
Yeah.
That's better?
Yeah.
All right.
Okay, I have a question. Where did you get the 2.998 from?
It is given to us on number 4.
99.
It says, given that the frequency is given as the speed of light divided by the wavelength, where the wavelength C is equal to 2.998 times 10 to the 17 nanometers per second. So it's a constant that is given to us. All right, so then we're gonna divide it by the wavelength, and from our first readout from the spectrometer, the wavelength is 410 nanometers. So by factor method, we're gonna see that the wavelength will be equal to 2.998 times 10 to the 17 nanometers per second divided by 410 nanometers. So nanometers will cancel out, and you divide 2.998 times 10 to the 17 by 410, and in that operation, all you're going to do is punch it in your calculator, and you're going to have it as 7.312 times 10 to the 14. Now, this seconds didn't cancel out, so we can write it as per second. And that is the value we're going to put in this middle column, which will be 7.312 times 10 to the 14. And the unit is per second. So again, it tells us that to calculate the energy of the line, so energy E is equal to Planck's constant times the frequency, and the value of Planck's constant, it is a constant that is given to us, it is 6.626 times 10 to the negative 34 joule second. So then we can put this here, the Planck's constant 6.626 times 10 to the negative 34 joules second, multiplied by the frequency, which will be 7.312 times 10 to the 14 per second. So here, this second is a numerator, and this second is denominator. So they will cancel out. Then we'll multiply this by that, and you can see that it's probably going to be something very close to the negative 20. But you're going to do that in your calculator. If the one I did in my calculator, it came to be 4.845 times 10 to the negative 19, and the seconds have canceled out, and the unit is a joule, and that is what I will put in this column. There's no need putting joule here because it's already identified in the column. Is that clear? Any questions? All right. So using the same equation of frequency and energy, we find the values for when the wavelength was 434 nanometers. So because this is a constant, I can just wipe that off, and it's going to change this value, okay? And it's going to change that value, and it's going to change this value. So what we're going to do is then the c, speed of light, divided by 434 nanometers. 434 nanometers. And the nanometers will cancel out, and you're going to
What's-
divide.
Professor? Oh, never mind.
You got it?
Yeah.
Okay, when we divide the speed of light by the wavelength, then it's going to give us 6.908 times 10 to the 14, and of course it is per second, which means this number of waves are completing in 1 second. Using,
Where it says V equals 2.998 times 10 to the 17th power.
Oh.
It's next to the 17th. Is that nanometers?
nanometers, yeah, and m.
And M, okay.
And then you divide it by the wavelength, which is 434 nanometers.
So divided by 4.
And then those nanometers are canceled out, correct?
They cancel out, yeah.
Okay.
And then you punch that number in your calculator, and you're gonna get this value. Do you have a calculator? Do you have a calculator that has a scientific notation?
Not yet. I'm waiting for it to come in the mail.
Oh, okay. All right, so when you get it, you be sure you learn how to use it, because not all of them are the same.
Okay.
Some are straight punching, and the others are what we call the reverse polish, which means you're gonna do something different.
Really quick, just for the woman who doesn't have the scientific calculator, a different student actually gave me one that if you have an iPhone or if you have a Samsung or whatever kind of phone, it's one to download. It's actually called Panical, and it gives you a scientific calculator just to use, and it's a free app.
You said
Yeah,
hand
yeah.
or pan?
Yeah, you can. Yeah, you can. In fact, your cell phone has two formats. First of all, your cell phone gives you just this, ordinary, multiply, divide, and subtract. Then there is how you go into the system, and it will be able to give you the expanded functions.
Yeah, the app is actually called Panical, like PANECAL.
Panical.
Yes.
Okay, so which means the
Thank you.
it's all calculation. That is okay. So did you learn how to use it?
Yes.
All right, good. So now in this we have calculated the frequency. Now we're gonna multiply that frequency by Planck's constant, and it will give us this number, this number here multiplied by the frequency 6.908 times 10 to the 14 and per second. So in this, the second is our numerator. In the frequency, it is our denominator. So they will cancel out, leaving you joule as the unit of energy. So if
Does
you-
that, is that 6.90710?
we are working with three significant figures. So what did you get it? When you multiply this number by that number, what did you get?
I'm confused with the numbers that are, it's 6.908. I can't, because I can't see that well.
Can you
It's
read
kind
the
of-
numbers to us?
It's 6.908 times 10 to the 14.
Thank you.
Yeah, all right, so multiplied by 6.626 times 10 to the negative 34. So what did you get?
Yeah.
You gonna tell me what you got?
Cool.
I got
I-
4.324408 times 10 to the negative 19.
So what did you get?
4.324408.
No,
Times- no?
it wouldn't be 4.3.
Oh.
Do it again. 6.626 times 10 to the negative 34 multiplied by 6.908 times 10 to the 14. And,
I got
okay, what did you get?
I got 4.577 times 10 to the negative 19th.
That's correct. So this number we're going to put over here, 6.908 times 10 to the 14. And the energy of that wave will be 4.577 because the 2 is less than 5, so we don't round it off, and times 10 to the negative 19. Okay, so 4.577 times 10 to the negative 18 joule. Notice that we are maintaining our answers to 4 significant figures because it gave us 4 significant figures here, and it gave us 4 significant figures here. So all our numbers should be 4 significant figures. Otherwise, you're going to lose points. Is that are we on the same page now?
Yes.
Okay, so when we have done that, we can do the same thing for 487 nanometers. We find the frequency of that wave and the energy of that wave. So we can again wipe off this one that is the variable and this one that is the variable and the answer that is the variable, and then we can put in the values of the variable. So this here will be divided by 1 over 487 nanometers. There should be a nanometer here, please, which will cancel out. And when you cancel that out, then the value should be 6.156 times 10 to the 14 second. All right, so who was doing that calculation for us before? Is Stephanie, is that you?
Yes, that was myself.
That's, okay, Stephanie, can you again punch in 6.626 times 10 to the negative 34 JS times 6.156 times 10 to the 14 per second. So
Yes.
this cancels that. So what do you get?
I got 4.079 times 10 to the negative 19th joules.
Very good. So that is 4.079 times 10 to the negative 19 joules. This is 7. And that is the number we're going to put here, 4.079 times 10 to the negative 19 joules. Okay. All right. So now we want to look at the last wavelength that we measured, and that was 657 nanometers.
Oh, what was the third middle one?
Oh, sorry, I didn't write it. So it should be this thing here. It should be 6.156 times 10 to the 14. All right.
For the second one, was it 4.079 or?
For the second one, this one?
Yeah.
This is 4.079, yeah,
Okay.
times 10 to negative 19.
Okay, thank you.
Okay, so now we want to look at the fourth wavelength that we determined. And this was 657. Again, the speed of light is constant. The wavelength changes. And of course, there is nanometers per second. And this value should change. And you should also change here, which means that this final value, joules, should also change. So this will be the speed of light in nanometers per second divided by 657 nanometers. And the nanometers will cancel out, and you divide 2.99 times 10 to the 17. You divide it by 657. So what did you get, Stephanie?
For that one, I got 4.563 times 10 to the 14th.
4.563.
Yes, times 10 to the 14th.
All right. 4.563 times 10 to the 14th. Again, because S, the second is still there, so the unit is per second. And this number is what we're going to put here, 4.563 times 10 to the 14, and the second is down here so that it cancels that. And what will be the value you're gonna get there?
.023 times 10 to the negative 19.
3.023
23?
times 10 to the negative 19. And of course, the unit is joule. And so this number will go here, 4.563 times 10 to the 14. And this other one will go here, 3.023 times 10 to the 19, negative 19. And it's in joules. All right, so you can see that the shorter the wavelength, the larger the energy, which means if it is sluggish, it doesn't have enough energy to penetrate the atmosphere. And that's why when you turn on that your wonderful radio in your car, and it's assuming that you are using the amplitude modulation, the AM channel. So 1070 should be a more powerful radio station than 727. So that if you were driving through a mountain range, you will be more likely to still receive the 1070 than the frequency, all of them have positive 10 to the 14. So we say that the energy depends on the frequency. So if we were to plot E in joules, so because they are all of the same scientific notation, we can just say E by 10 to the negative 19. And because the independent variable is the wavelength, and they also have the same exponent, which is 14, we can say that the wavelength, lambda in nanometers by 10 to the 14. So then what we'll be concerned with is to plot 410, 434, 487, 657 on the x-axis, and then the 4.845, 4.577, 4.079, 3.023 in the y-axis. And that should give you a slope that will tell you the frequency of that combination of wavelength and energy.
And can you tell me what goes under the x-axis again?
The wavelength.
So row number 1 goes on the bottom and row number 3 goes on the side.
Yeah. Because the energy depends on the wavelength and not the other way around. So you did very well in plotting the thing from yesterday, those who have submitted. So you're gonna plot this also and find the slope. Okay? All right. So now moving on to number 5. So now it says for us to investigate the emission spectra for our different elements, this time helium. Helium is the next element after hydrogen on the periodic table, and it has 2 electrons. So the big question, do you think the emission spectra from atom with 2 electrons instead of 1 will be different, much different from that of hydrogen? The answer is yes, because what is creating that particular emission is the electrons. And I tried to do this, the next step, number 6, 7, and 8, and the thing wouldn't respond. So I think he went to sleep. And I've been trying to get that to work and it didn't. So we're just going to plot this particular graph as a part of the homework. And the next homework we're going to do, you're going to go to the to a canvas shell, and you go to Files, and there is a file that is placed there that is called the atomic fingerprints. So you read that, and then you do the pre-lab, just the pre-lab. There are 16 pages, and I don't want to see 16 pages on my stuff. All I want to see is that the answer to the pre-lab that has, I think, 7 questions. Any questions?
So there's 2 parts to our homework. You want us to do the slope and then the canvas, the file on canvas for fingerprint, atomic fingerprints.
Yes, please.
So we do the slope that you left blank pretty much on the board, right? Like we have to come up with the slope that's on there.
Yeah, that is, you know, the homework on this particular number is for you to be able to choose an appropriate scale for the energy and for the wavelength. In other words, you see that you know this went from 410 to 657. So maybe you start from 400 right here, and then have 410, 434, 487, 6 something. So there is no need giving us an empty space here and an empty space there. When you are plotting a graph as a practice of what you should do, you make sure that you use the entire graph sheet. And doing this one too, you see that they're all within 3, 4. So you're not gonna go 3 and then on 4 and leave all this. Then you cannot squeeze everything here. You try to spread out the scale so that maybe you have 3 here, then you have 3.2, 3.4, and then you get maybe 4.8 over here, so that it becomes spread out
Okay.
and not crowded in one place, you know, like it is under stress.
But isn't line number 1 845 not within the 4 point?
This one here,
I can't. You're covering it. I can't see it.
that is 4.845 times 10 to the negative 19.
Oh, it's 4.845. Oh, I wrote it down.
Yeah. And the next one is 4.577 times 10 to the 19, 4.079 times 10 to the negative 19, and 3.023 times 10 to the negative 19. And that is why I said all you have to worry is this, establishing a usable scale for this, because the exponents are the same, 10 to the 19. And on the same, if you were to plot the wavelength, it is also on the same thing. But what I want you to plot is the wavelength and not the frequency. So the wavelength is 410, 434, 487, 657. Okay.
And you said that if possible, we can do the slope on Excel, correct?
Yeah.
Okay.
Yes. you put these numbers in your Excel and you call up the slope and click on it, and it's gonna give you the slope. In fact, sometimes it can even give you the dotted line where the slope is supposed to be.
Does anybody have a MacBook that can help me find a graphing chart?
So you have a Macintosh,
I have a MacBook.
a MacBook. I don't know nothing about that.
I have a Mac, but I have no idea how to use a graphing chart on here. I'm still
Yeah.
learning.
Okay. I was trying it yesterday, but my team just had to do the Excel on theirs. So, okay, thank you.
So use the program you know how to use so that you can get your score, and not the program you don't know how to use. Then you mess it up and you don't get a perfect score. Like I said, if everybody at the end of the semester gets 100%, that's what you got, because you did the work. Okay. And in this type of work, it is easy to lose points, because if you didn't do it in the correct significant figures, you're going to lose points. And if you solve the problem and you don't indicate the unit of the answer, you're going to lose points. Okay.
So we're gonna calculate the slope, and then you want us to do is it the pre-lab for atomic fingerprint today?
No, that thing is making me.
I'm having a hard time for you.
It's making kind of noise. Okay, can you try again?
Oh, sorry, I was just sending the homework. So we're gonna be calculating.
All right, so
with all and then are we doing the atomic fingerprint assignment?
You're cutting out completely. We can't understand you at all.
Okay, Mindy, I think I got an idea
Oh,
what your question is all about. So what's the answer to your question, I suppose, is that you should have made this table, copied it in your notebook or whatever you have here now, and then you plot a graph of the energy on the y-axis and the wavelength on the x-axis.
Oh, I know that. If you
Okay, the other homework is the one you go to your Canvas shell and open the files, and it says atomic fingerprints, and you do the pre-lab that is described in that particular handout.
I have a quick question for you on what's on the board.
Okay.
For the left column that you said it was the wavelengths, I'm just trying to read it just to make sure. Is it 410, then 434, 457, and then
no, 487.
Okay, so 410, 434, 487, 657?
Yes.
Okay, perfect. Thank you.
You're welcome. Okay, so for this atomic fingerprint lab, all I want to see is the page or pages that contains the pre-lab and not all the 16 pages, please. And again, be sure that you list the names of your members and the section, whether it is AM or PM, or it is 9074 or 9078, or 8 AM or 3:35 3:35 PM. So you choose any of those three methods of indicating whether you are, where you belong. Because I made the mistake of using the same color for morning and afternoon. So if you just say your color, then I have to go to the roster to check who you are and where you belong. So save me that extra 2 steps.
Are we?
By indicating whether you're in the morning section or in the afternoon section.
Professor.
Yeah.
So for the slope on this one, is it possible for it to be negative?
Oh yes, if you can see, really, you can see that while this is increasing, this one is what? Decreasing.
Right.
So the leaning will be different from what we saw yesterday.
So are we done with the lecture, the rest of the lab today? And then we just have to do our homework?
Yes, we are done with the rest. We're done with the lab. And in fact, very soon it will be like this, especially if the Beyond Lab thing cooperates. The labs will be short, and there is only a few times when it will be long. But tomorrow's lab, if it works, will also be short. Okay.
Okay, thank you.
Right.
Okay, thank you.
You're welcome.
It was so much easier today.
Well, actually, it's not that it is easier, but that you now have an idea of what we're talking about from the lab yesterday.
Right.
And so now you have an idea of what we're talking about. Okay. Any question now? Again? All right. So Jessica and Haley, you now know where your new group.
I sent a message in the Pronto so that you guys can send your numbers and that we can get together to establish homework and stuff like that.
Okay, thank you.
So I love the way you guys are cooperating. Please keep it up. That is what learning is all about.